So we'll talk about kinetics, or the equations of motion, specifically using tangential and normal components. So we'll define, so we have a particle moving on some path. We'll define a tangent direction and a normal direction, which is perpendicular to this tangent direction and points to some center radius here, O. And in these problems, we of course are going to have we're going to have to break things down into forces, applied forces that are, and sum all these up, that are tangential, and we'll have the component of forces that are applied. We'll figure out their normal components too. So summation of our forces then we'll set those equal to mass times the acceleration, and the acceleration will also be broken down into components. So this will look like sum of forces in the t direction, u of t, plus sum of forces in the n direction, u sub n, and it's going to equal, I'm going to leave some space here because I'm going to put something else in here. It's going to equal the mass times the acceleration in the tangential direction plus the acceleration in the normal direction. Now what I want to stick in here is another term that pops in, because this motion is defined in a plane, but we can also, sometimes we can, for example, have this as a plane that's horizontal, but we still have some forces acting out of plane that we can deal with, and like weight, for example, if this was a horizontal track, we could then call these summations of forces in the B, u sub B, where u sub B is coming out of the plane, like so. Okay, so we of course can analyze these problems by summing forces in the tangential direction and setting them equal to mass times the acceleration component in the tangential direction, or summing forces in the normal direction equals mass times the acceleration magnitude in the normal direction, and we can sum our forces in the B direction, and we have no acceleration in that direction, so it equals 0. Notice here that in this type of analysis, this a sub n here always points to the center. So it's always going to have that direction. And again, there is no acceleration. No acceleration here in the B direction. So let's do a fundamental problem here. We have a spinning disk, and we want to find the speed just before slip. Of this block. So the disk is spinning, and we want to find speed of the block just before slip. So we need to know what our coefficient of friction is. So currently we have coefficient of static friction going here, and that's 0.3. Okay, so where do we begin? First off, let us set up our free body diagram. So notice I have this, I orient my axes so that the normal points towards the center and the tangentials in the tangential direction as this thing spins. And B is out of plane. So I could set up a block like this where this is the B direction and this is the normal direction. Then my situation is I'll have a normal force here from the surface of the disc. I'll have a weight of my block then, and this is in the B direction. You can see why we want to use sometimes the B direction. And then this will lead to friction. Now, since this block wants to move outside, our friction will resist that in this direction. And then this equals the situation here with mass times the acceleration. There is no acceleration in the B direction. So let's figure out what the normal is, and we'll start by summing forces in the B direction, and we get N, I guess I'm defining B positive up, minus mg. So therefore our normal force equals 9.81 times, well, we don't have a mass, so we're just going to leave this as mg. So 9.81 times n. Since we're dealing with meters over here. Okay. Let's sum our forces in the normal direction. So now we're going to get F is going positive here, so this is what we're going to call positive. So F equals M, a normal, and essentially F is our coefficient of friction, 0.3 times 9.81 times our mass. This equals our mass times our normal acceleration, which is going to be v squared over r. Again, that's the formula for the normal acceleration. Okay, and this is why we didn't have to worry about this, because we can cancel the mass out on either side, it seems. And r we can replace with 2 meters. So solving this for v, we get 2.43 meters per second.